Next up, 4.9, we're going to graph and solve quadratic inequalities, which really just means we're going to shade above or below a parabola. We might be using a dashed line or a solid line. The steps are exactly what you'd probably expect. We're going to graph the parabola, which we should already know how to do. We're going to make a dashed or solid line depending on what inequality symbol we see. And then we're going to shade above or below just like we've done in the past. So you have learned a lot of ways of graphing a quadratic inequality. You've learned how to graph using intercepts. You've learned how to graph using a table. You've learned how to graph using a vertex form. You can use any one of those methods to graph. I think the easiest way is to find the vertex and then find a couple more points. Easiest way for me to find a vertex is negative b over 2a. You don't have to do it this way. This is just my choice. Go ahead and find a vertex or graph this any way that you prefer. Talking about how to graph this parabola is not my primary objective here. If you need help with that, go back and look at one of the previous lessons from this chapter. I do have to shade though. It says y is greater than, so I'm going to shade above. Notice I used a dashed line. It's because it said y is greater than, not greater than or equal to. And that's it. When you graph your parabolas, be sure you get your vertex in the right place, and then have at least some other points that are in the right place, whether it's x-intercepts, y-intercepts, have something that makes sense. Okay, go ahead and pause the video and try to come up with a good range of values for d and w before you even talk about graphing this parabola. There actually was not any necessarily right answer for the right-hand side of these inequalities, but you definitely can't have a diameter smaller than 0. So we should probably say our diameter has to be bigger than 0, and our weight in pounds would also have to be bigger than 0. You don't lift negative pounds. I chose 5 arbitrarily, no particular reason. Once I chose that 5 though, you should be able to come up with the 37,000 by going 5 squared times 1480. Then we can draw our graph. We know it's a parabola. We know it's all in quadrant 1. You could plot a couple more points to be more accurate if you want, but it's not really necessary. What we really have to do is shade the direction that we're supposed to. We can support weight below this amount. If we have weight higher, we're going to break the rope. And that's it. Graphing a system of quadratic inequalities. The hardest part of this problem is not going to be the new material. The hardest part is going to be actually graphing these quadratics. That's not the focus of this lesson, so I'm not going to talk about it in the video, but there's plenty of resources in chapter 4 that talk about how you can graph various parabolas. So that's your first step. Graph your parabolas, use a dashed or dotted line. A dashed or solid line where appropriate. Once you've got your parabolas graphed, all that's left is to decide where do I shade. I know I want to shade under inequality 1 and over inequality 2. So it looks like I'm bound in here. That's it. Again, if you're having trouble graphing these parabolas, go back and look at your other chapter 4 resources or come see me. At this point, you can try these on your own or do that later. Example 4, solve a quadratic inequality using a table. That's got to be the worst advice I've ever heard. Don't ever solve a quadratic inequality using a table. The best way, in my opinion, of solving a quadratic inequality is to find the zeros and then mark off those zeros on a number line. And I'll tell you what to do from there. So your first goal is to find zeros to this equation, which you should know how to do. So pause the video and find those zeros, see if you get the same thing. Next up, we put those zeros on a number line. I'll explain why in a moment. Now when we plug any number int that's to the left of -3, either we're going to get a positive answer or a negative answer. So maybe -4. Plug in -4 to this guy and see if we get a positive or a negative. Plugging in -4, we get -6 times -1. That's a positive. Then we go between -3 and 2. Choose a number between -3 and 2 that's easy. The easiest one I can think of is 0, and plug it in. -2 times +3, negative. Then choose a number bigger than 2, like 3. 3 minus 2 is 1. 3 plus 3 is 6. Multiply those, you get a positive. So now we can figure out where this was true. And one little mistake I made. We shouldn't have said equals, we should have said less than or equal to. When we have a positive number, are we less than or equal to 0? Of course not. When we have a negative number, are we less than or equal to 0? Yes. So anything from -3 to +2 is okay. When we have a positive number, are we less than or equal to 0? Of course not. So the only region that worked was -3 is less than x. Less than or equal to x is less than or equal to 2. We could have seen that on a graph as well. What that would have looked like if we would have had our zeros at 2 and -3. And notice this whole thing is less than or equal to 0 only from -2 to positive, or -3 to +2. That's it. So we're going to actually graph one on example 5. Go ahead and draw this graph. You'll have to find the x-intercepts so you can figure out what values of x make this true. Again, my goal is not to teach you how to graph in this one. You got to be able to come up with that graph on your own though. The easiest way I think to find those x-intercepts is using the quadratic formula. Unfortunately, we don't really know where to put those numbers because they're not nice. You got to come up with a decimal for these. Makes it a little trickier. Make sure you know how to get a decimal for those. We get one at 1.2 and one at -1.7. We also know this parabola opens up, so I don't actually care about where the vertex is this time, since I just want to know where this whole parabola is positive. And it looks like it's positive whenever x is bigger than 1.2, or when x is less than or equal to 1.7, -1.7. So we don't need to know exactly where the vertex is to do this, because we only care what's happening right around the x-axis. That's it. At this point, you can try one on your own, or do it later. Go ahead and pause the video and try to figure out what's going on here. Looks like we've got an equation that tells us how many teams participating in a robot building competition, and we want that number of teams to be bigger than or equal to, looks like we just want greater than 100. We can use the quadratic formula here. Looks like we're going to have some messy numbers, so calculator is definitely going to be used. But we don't want that 100 there. We need to move it over so we can have a 0. So our first step should be to move that over. At this point, use the quadratic formula to come up with answers that make sense. You should know what I mean by answers that make sense by this point. The only answer that seemed reasonable is x is greater than 4.2. However, if you stop there, you actually missed the problem. The answer should be 4.2 is the smallest. And go ahead and pause and think about what the biggest value of x that we're allowed to have is. If you thought 9, you're right. Because we're told that x can only be between 0 and 9 to begin with. And we want to know what years, we're still not done actually, we want to know what years the number was greater than 100. So we want values of x bigger than 4.2. The first year bigger than 4.2 would be 5. So we add 5 to 1992, 1997, 2, then we add 9 to 1992, 2001. There's our final answer. And solve a quadratic inequality algebraically. This is where you do it the same way I did in example 4. So go ahead and make one side 0. Put your plus or minus signs on a number line and come up with your final answer. See if you come up with the same thing as me. Before I put up my final answer, remember this time we want positive answers. So we're looking for regions that have a positive above the number line, not a negative. And there's 2 this time, so we say x is less than -3 or x is greater than 5. We don't use the and this time because we're not shading in between, we're shading on the outside. It's an or type problem. At this point, you can try these on your own, or you can do that later. Regardless, we are at the end of this lesson.